Good morning students. Welcome to grade 9 mathematics class. Today we are going to learn the continuation of the previous class. In the previous class you learned about equivalent set, equal set, universal set, subset, isn't it? In an equivalent set, number of elements are same, and in an equal set, all the elements are same, isn't it? Today, let's do the exercise 1.2 third question. Let's write the question. Which of the following sets are equivalent or unequal or equal sets? First subdivision is A is the set of vowels in the English alphabets and V is the set of all letters in the word vowel. Okay, let us do. So A is equal to set of vowels in the English alphabet. So A is equal to, what are the vowels in English alphabet? Set mark, that is flower bracket or curly bracket. A comma, E comma, I comma, O comma, U are the vowels, isn't it? So A set. Then B is given set of all letters in the word vowel. So we have to write B is equal to flower bracket V comma O comma W comma E comma L. Okay. Now we have to check it whether it is equal set or equivalent set or unequal set. We know that equal set in the sense both set having same number of elements. Is it same number of elements? Is it same elements? No. Here AEIOU, here VOWEL. So different elements are there, but the number of elements are same, isn't? So if the number of elements are same, we can say both the sets are equivalent set. Okay. When we say equivalent set, if the number of elements are same. Okay. Here in the set A having 5 elements. 1, 2, 3, 4, 5 elements. Similarly, the set B also having 1, 2, 3, 4, 5 elements. Okay. So this both the set A and B can be say equivalent set. So let us write the number of elements in the set A, that is n of A equal to 1, 2, 3, 4, 5. Okay, comma. N of B is equal to 1, 2, 3, 4, 5. So next we can write n of A is equal to n of B. Therefore, A and B are equivalent sets. Okay. Therefore, the sets A and B are equivalent sets. Okay. Next do the fourth subdivision. Okay. Second and third are the homeworks for you. Fourth subdivision is G is equal to X such that X is a prime number and 3 less than X less than 23. H is equal to X such that X is a divisor of 18. Okay, let's do the solution. Listen carefully. So G is equal to, what is G? X is a prime number and which is 3 less than X less than 23. So here what are the numbers we have to write now? In between 3 and 23, what are the prime numbers are there, that we have to write. In between 3 and 23. 3 won't come, 23 also won't come. Why no? Less than is given. If it is less than or equal to 3 and 23 can be taken. Here less than is given, so 3 and 23 we should not take. Okay. So in between 3 and 23, what are the prime numbers are there, that alone we have to write. So, tell the prime numbers. What are the prime numbers in between 3 and 23? 3 after we have 5. Then 7. Next prime number 11. Next 13. Next 17. Next 19. Okay. Then height. What is the height set? Height is equal to x is a divisor of 18 like that given, is it? What are the divisor of 18? 18 can be write 1 into 18 is equal to 18. Then 2 into 9 is equal to 18. Then 3 into 6 is equal to 18. Any other chance? Yes, again 6 3s are 18. 9 2s are 18, 18 1s are 18. Same only. Okay. So repetition no need. So what are the divisors here? 1, 2, 3, 6, 9, 18. Okay. So 1, 2, 3, comma 6, comma 6, comma 9, comma 18. 9, comma 18. Now we can count the elements, number of elements. So question is whether it is equal set or equivalent set or unequal set. Okay. So first of all we have to check it, is it equal set? We know that equal set in the sense both set having same elements. Is it same elements? No, different elements. Okay. So it is not an equal set. Then we can move to the whether it is equivalent set or not. Okay. So equivalent set in the sense both the set having same number of elements. Number of elements. So in the set G having 6 number of elements means H also should have the 6 elements. Let us check it. Okay. So n of G, number of elements in the G set, that is n of G. N of G is equal, how many numbers are there? 1, 2, 3, 4, 5, 6. Okay. N of G is equal to 6. Similarly, n of H. N of H is equal to 1, 2, 3, 4, 5, 6. Okay. So n of G is equal to n of H. Okay. So number of elements are same. So we can write therefore G and the set G and H are the equivalent sets. Okay. There is a note in page number 10. Okay. First one is, if A is the subset of B and B is the subset of A, then A is equal to B. What did you understand here? If A is equal to B, then we can say A is the subset of B and B is the subset of A. Okay. A set and B sets are same. If the A set and B sets are same, we can say A is the subset of B and B is the subset of A. Okay. Second one is, empty set is a subset of every set. Empty set is a subset of every set. Empty set in the sense we know that set contain no element. Set contain no element is known as empty set. That also subset of every set. Third one is, every set is a subset of itself. What is the third one? Every set is a subset of itself. Okay. Let's do the problem. Example 1.7. What is the example 1.7 now? Write all the subsets of A is equal to A comma B. Okay. What is given? The set A is equal to A comma B. Okay. The set A has two elements, A and B. Okay. We know that by the note we come to know empty set is a subset of every set, isn't it? So let's write the subsets of A are, first of all, empty set can be written. Okay. So empty set is an subset of every set. So empty set can be written first of all. Okay. What is mean by empty set? Set has no element. Okay. That is the empty set, comma. Then first element A. Okay. A is the subset of given set A. Okay. Small a. Then next comma. Next element B. Okay. B also next subset B. Then also we know that every set is the subset of itself. So A comma B is the subset of itself. So that also can be right. Okay. So how can we write A comma B also? Okay. Understood, students? Next, let's write the exercise 1.2 7th question. Okay, exercise 1.2 question number 7. What is the question? If A is equal to A comma B, close the bracket, write all the subsets of A. Subsets of A. Here, given A is equal to what is given? A comma, again flower bracket or set bracket, A comma B. Is it? Then close the bracket. We have to write the subset. We know that first of all empty set is the subset of all the sets. Is it? So subsets of A are first of all empty set or null set, comma, in first element A, okay, comma, then second element, that is A comma B, then this both elements together, comma, A comma, this A comma B. Okay, need to close the bracket here. Understood, students? Then next definition is proper subset. Okay, let A and B be two sets. If A is a subset of B and A is not equal to B. What is meant by A not equal to B? A and B are the different sets. Okay, not same. Then A is called a proper subset of B. We write A is the proper subset of B. For example, A is equal to 1, 2, 5 and B is equal to 1, 2, 3, 4, 5. In the set A has 3 elements and the set B has 5 elements. Here B is the greater set. Okay, so A is a proper subset of B. That is A is that we have to write A is the proper subset of B. Here B is the greater set, A is the smaller set. Okay, A and B are two sets. Then A is a subset of B and A is not equal to B. Then A is called a proper subset of B. We write A is the subset of B. Then disjoint sets. Okay, two sets A and B are said to be disjoint if they do not have common elements. Okay, in other words, we can say there is no common part, means A intersection B part is null set. A intersection B is null set. Okay, then A and B are said to be disjoint sets. Okay, what is it? Two sets are said to be disjoint if they do not have common elements. Okay, they do not have common elements, means A intersection B is equal to null set. A intersection B is equal to null set. Okay, there is no common. It won't be join. Okay. Next, example 1.8. What is the example 1.8 now? Verify whether the set A is equal to 20, 22, 23, 24 and the set B is equal to 25, 30, 40, 45 are disjoint sets. Okay. So, A is equal to 20, 22, 23, 24 and B is equal to 25, 30, 40, 45. So, disjoint set in the sense, you know the definition. What is meant by disjoint set? Two sets A and B are said to be disjoint if they do not have common elements. So, we have to check whether the sets A and B having common elements or not. Okay. For that we have to find out A intersection B. Okay, A intersection B is equal to A set intersection B set. Okay, A set is 20, 22, 23, 24, and the set B is 25, 30, 40, 45. Now compare the elements. Is it there any common elements in both sets? Here 20, 22, 23, 24. Here 25, 30, 40, 45. Is there any common elements in both sets? No. Is it? So, null set. So, A intersection B is equal to null set, or this one same empty set. Both the same meaning only, null set or empty set. Now, A and B are the, here A intersection B is equal to no element, null set, empty set. Okay. Therefore, A and B are disjoint sets. Okay, understood students? Next exercise 1.2, question number 5. Okay, what is the question number 5 now? State which pairs of sets are disjoint or overlapping. What is meant by overlapping? Joint set. Okay, disjoint or joint set we have to find out here. First subdivision, A is equal to F, I, A, S, and the set B is equal to A, N, F, H, S. Okay. So whether we have to check it whether the A set and B set are disjoint set or joint set. Okay. For that, A is equal to F, I, A, S, and the set B is equal to A, N, F, H, S. To find disjoint or join, what we have to find out first of all? Intersection part. If there are any common elements are there, we have to check it. So, A intersection B is equal to A set. First of all, A set is F, I, A, S, and the intersection of B set is A, N, F, H, S. After that, we have to compare the elements. Whether any common elements are there, we have to check it. Okay. Is there any common elements in both the sets? Yes, isn't it? What are the common elements? F, is it? So, we have to write F is the common element. Then, is there I in both sets? No. I is only in A set. So, we cannot select that. Then next A is there. Okay, A is in both sets. So we have to write A. Next S also is there in both sets. So we have to write. Okay. So A intersection B is equal to F, A, S. So if there is a common elements, we have to say that sets are joint sets. Okay, there is a common elements. Therefore, A and B are joint sets, means overlapping. Okay, understood students? Next, second subdivision. Second subdivision is C equal to X such that X is a prime number, X is greater than 2, and D is equal to X such that X is an even prime number. Close the bracket. Okay. Here C is equal to C is equal to x such that x is a prime number but x greater than 2, and D is equal to x such that x is an even prime number. So what is C? Let us write. Okay, C is equal to C is a prime number but x is greater than 2. So 2 won't come. Above 2, what are the prime numbers we have? Above 2, 3, 5, 7, etc. No end. It was mentioned x greater than 2. So above 2, what are the prime numbers are there? All the prime numbers can be right. Okay, so etc. symbol we have to use. Next, D is equal to even prime number. So what are the even prime number? There is only one even prime number, that is 2. 2 alone. Okay. Now we have to find out whether it is joined or disjoint, means disjoint or overlapping. So for that we have to find out C intersection D. C intersection D is equal to 3, 5, 7, etc. intersection D set is 2. Now check it whether is there any common elements in both the sets? No. Okay. So empty set. Okay. C intersection D is equal to empty set. Therefore C and D are what answer we have to write? Disjoint sets. Okay. No common, so disjoint sets. Okay. Now third question is, third subdivision is E is equal to x such that x is a factor of 24 and F is equal to x such that x is a multiple of 3, x is less than 30. Okay, how can we do this one? So here E and F are the two sets given. E is equal to factor of 24. What are the factors of 24? 1, 24 is divisible by 1 and 2 and 3 8s are 24. No? So 3, 4, 6 are 24. 4 after 6. Then 8 3s are 24. No? 8. Then 12 2s are 24 and 24 also. Okay. Then the set F is equal to multiple of 3 less than 30. What are the multiples of 3? 1 3 is 3. 2 3s are 6. 3 3s are 9. 4 3s are 12. Next 15. Then 18. Then 21. 24. 27. 30 won't come. Less than 30 is given. So 30 we should not take. Okay. Now we have to check any common elements are there. So for that E intersection F is equal to E set. That is first 1, 2, 3, 4, 6, 8, 12, 24. Intersection. Next F set. That is 3, 6, 9, 12, 15, 18, 21, 24, 27. So here which are the common elements? 3, 3, 6, 6. Is it? Then 12 is there. 24 also is there. So we have to write. Okay. So E intersection F is equal to 3, 6, 12, 24. Okay. So What type of set this one? Which is equal to, is there any common elements? We know that that is joint set. Okay. Therefore, E and F are overlapping. Okay. Overlapping sets. Now homework. Today you have exercise 1.2 third question, second subdivision and third subdivision. Okay. So you have to watch the video properly, learn properly, and after that complete the homeworks also. Okay. Thank you, students.